Now I am taking an example where some change in the radius is made. Then how we compare the surface areas and volumes of a sphere in two cases. The question is, the radius of a spherical balloon is increased from 7 centimeter to 14 centimeter. Initially there was a balloon with the radius 7 centimeter. When air is pumped into it, inflated, and the radius become 14 centimeter. So there are two situations. When air is pumped in a spherical balloon of radius 7 centimeter, radius become 14 centimeter. Find the ratios of their surface areas and volumes. How we will find their ratios? So radius in the first case I am writing R1, that is 7 centimeter, and in second case it is 14 centimeter. Surface area in first case will be 4 pi R1 square and surface area in second case will be 4 pi R2 square. We want to calculate their ratios of surfaces. So 4 pi and 4 pi get cancelled. It left with R1 square upon R2 square. So this becomes 7 into 7 upon 14 into 14 because R1 is 7. So this comes out to be 1 by 4. Hence the ratio of surface areas become 1:4. Second, ratio of their volumes, that is V1 upon V2. V1 is the volume in first situation. This is given by 4 by 3 pi R1 cube upon in second situation 4 by 3 pi R2 cube. This become 4 by 3 pi, 4 by 3 pi get cancelled. R1 cube upon R2 cube, that is 7 into 7 into 7 upon 14 into 14 into 14. This become 1 by 8. So I can say that the ratio of volumes V1 is to V2 has come out 1:8, and ratio of surface areas S1 is to S2 is 1:4 as shown in the first situation. So this is the way to compare the surface areas and volumes under various conditions. Now I am taking an example where the cost of painting of any hollow is spherical. Now I am taking an example where the cost of painting of hollow hemispherical shaped bowl or object is required to calculate. The internal and external diameters of a hemispherical vessel are 24 centimeter and 25 centimeter. Diameter outer external is 25 centimeter and diameter internal is 24 centimeter. So with this way I can say radius of outer part is 25 by 2 centimeter external one, and radius internal is 12 centimeter. Radius is half of the diameter. Find the cost of painting its total surface. As and when we talk about the total surface of any hollow hemispherical object, the formula is, if I tell you this is the total surface area of hollow hemispherical object or vessel. It is given by 2 pi capital R square, that is the external radius, that is external curved surface area, plus 2 pi, that is what? Internal one, we call it small r square, plus pi capital R square minus small r square. This is the area of ring or edges of that thickness. I can show you like this here. This shaded dotted part is the area, this one, and internal is this one, external is this one. To calculate the area, I will say it is 2 pi. 2 pi is common from these two. It is capital R square plus small r square plus pi. R square minus R square by algebraic identity can be written as R plus R into R minus R. This become 2 pi into R square, that is 25 upon 2, 12.5 whole square, plus internal R square, you can say it is 12 whole square. So this become 2 pi into 12.5 square plus 12 square plus pi into R plus R, 12.5 plus 12 into 12.5 minus 12. Now this value is coming out to be 2 pi, 12.5 whole square, it is 156.25 plus 12 whole square is 144 plus pi into their sum is 24.5, their difference is 0.5. This become 2 pi into summation of these two values become 300.25 plus pi into this value become, when 0.5 will be multiplied to it, 12.25. So the answer is coming out to be, when this is multiplied, 600.50 pi plus 12.25 pi. If I ask you to add these values, you will say it is 612.75 pi, 612.75 pi centimeter square. This become the total surface area, net area to be painted. If I put the value of pi to be used at 22/7, then answer of TSA in the final form will come 612.75 into 22/7. So first we will multiply it by 22 and then we will divide it by what? 7. So it will be 1925.79, 1925.79 centimeter square. Cost of painting of 1 centimeter square is rupees 0.05, that is 5 paisa. Cost of painting, total surface area will be 1925.79 into 0.05. The product of this value is rupees 96.29. You can say the cost of painting the total surface area of this hemispherical bowl of the given diameters at given rate is rupees 96.29, that is rupees 96 and 29, or you can say 30 paise. Now another question, if surface area of a sphere is 5544 centimeter square, find its volume. Surface area of a sphere is given by 4 pi r square. So you can say 4 pi r square's answer is 5544, or r square become 5544 upon 4 pi. R square become 5544 upon 4 into 22/7. Its calculation is coming 441 and its square root is 21 centimeter. This become the radius of sphere. We want to calculate its volume. We can say the volume of sphere is given by 4 by 3 pi r cube. You can say 4 by 3, 22 by 7, r cube means 21 into 21 into 21. The simplified form of this is 38808 centimeter cube. So with the help of curved surface area or total surface area of a sphere, on comparing we calculated radius. Radius is applied in the formula of volume. So it become 38808 centimeter cube is the volume of this sphere whose surface area is 5544 centimeter square. Now one more problem based upon recasting of hemisphere to convert in some other shape. The diameters of external and internal surfaces of a hemisphere are 10 meter and 8 meter. Hemisphere is melted and recast into a cylinder of diameter 14 meter in a solid cylinder of diameter 14 meter. Find its height means the find height of cylinder. That is, we need to calculate the height of cylinder if it is obtained only from the volume of what? So obtained by melting this hollow hemisphere. The question is, we can say the volume of hollow hemisphere is same as the volume of solid cylinder so obtained. What is required? The height of solid cylinder so obtained is required. I can do one thing. We know that volume of what? Volume of hollow hemisphere. Volume of hollow hemisphere is 2 by 3 pi. The volume of hollow hemisphere is equals to 2 by 3 pi capital R cube minus small r cube. Volume of solid cylinder. Volume of solid cylinder is given by pi. You can say radius is x, then x square, and if height is h, then h. Why I am taking radius x? Because capital R and small r are used for the radius as external and internal of hemisphere. You can say that volume of hollow hemisphere is equals to volume of solid cylinder. That is the value of 2 by 3 pi capital R cube minus small r cube is equal to pi x square h. So this pi and pi get cancelled. Put the value of capital R, that is what? Half of the diameter 5. Internal half of it 4. So this become 2 by 3 into 5 cube minus 4 cube is equals to x square. Diameter of solid cylinder is 14. So this become 7 square into h. So what you can call the value of h? H is equals to 2 by 3 into 5 cube is 125 minus 4 cube is 64 and divided by 7 square, that is what? 49. If you will simplify and solve it, you will get this result will come as 4 by 3 meter. Hence, if a hollow hemispherical shaped object of internal diameter 4, external diameter 10 is melted in a converted into a solid cylinder of dia 14, then the height by comparing these volumes will come out 4 by 3 meters, or you can say it is 1.333 meters, or you can convert by multiplying it 100 into centimeters. Now one more example where the three shapes are to be taken, all three shapes together. A cylinder, I can show you here that there is a cylinder. If there is a cylinder, it has to be its radius and it has some of its, say, height h. A cylinder, a cone, there is one cone shape you know very well, this. A cylinder, a cone, a hemisphere. You must understand that what is the hemisphere? Hemisphere is the shape like this. This is the suppose hemisphere. A cylinder, a cone, this is cylinder, first thing, second is cone, this is the third one, you can say hemisphere. Have equal radii, that is the radius of each of the object is same. So you can say whatever is the radius of cylinder is same as of cone, same as of hemisphere. I can write here radius of cylinder is equals to radius of cone is equals to radius of hemisphere, and that is suppose r units, because all radii are same. A cylinder, a cone, a hemisphere have equal radii and equal height. You have to note here that height of hemisphere is always equal to its radius, because if this is the radius and this is also the radius, so I can say that the height of hemisphere is same as the height of its that is its radius. A cylinder, a cone and a hemisphere have equal radius, so I have written here that is radius of cylinder is equals to radius of cone is equals to radius of hemisphere is taken as r units. And equal heights, that is you can say height of cylinder is equals to height of cone is equals to height of hemisphere. But you know the height of hemisphere is same as the radius, so it is also equal to r. Find the ratio of their volumes. First is the cylinder. Volume of cylinder is pi r square h is to 1 by 3 volume of cone pi r square h is to height of sphere, that is what we are comparing, what height of hemisphere is always equal to radius. So the volume of hemisphere is 2 by 3 pi r cube as the usual result. Here one thing is to be note that this height and this height, these two heights are equal, that is height of cylinder is same as the height of cone and same as the height of hemisphere as mentioned in the question, but height of hemisphere is always equal to its radius, so these two h will also be replaced by small r, because in given that three heights, height of cylinder, height of cone, height of hemisphere are same, and height of hemisphere is always equal to the height of that is its radius. Now this become pi r square into r, because height is replaced by radius of hemisphere, and radius of hemisphere is same as the radius of cone and cylinder as given, is to 1 by 3 pi r square into r is to 2 by 3 pi r cube. We can take LCM 3. So after taking 3 as LCM, what is going to happen? This become pi r square into r become r cube, that is 3 pi r cube. If I have taken the LCM as 3, so here it is 1, so it will be 3 pi r cube is to 3 and 3 get cancelled, This left with pi r square into r is r cube. Then 3 and 3 cancelled. This is 2 pi r cube. You can compare, you can see for the ratio it is the simplest form. So you can say here this become 3 pi r cube is to pi r cube is to 2 pi r cube. Pi r cube, pi r cube, pi r cube get cancelled. This left with 3 is to 1 is to 2. So we can say if a cylinder, a cone and a hemisphere having same radii and same height, then we can tell the ratio of their volumes is 3 is to 1 is to 2. Similarly, you can extend to calculate the ratio of curved surface, total surface, etc.